Right. The first exciting part of the mole calculations is the reacting masses. So I'm now going to show you how to solve 2 or 3 examples and then let you try the worksheets provided. Now, don't get frustrated if you don't get it right straight away. From my experience, people make a mistake the first 3, 4 questions they do. So it takes a little bit of practice, but if you listen very carefully, I will mention the misconceptions so you can avoid them. The first thing I'm going to actually talk about is ratios, reacting ratios, to make sure you understand. So this has an imaginary 1 in front of it, technically. Okay, just like in maths, if you write x, it means 1x. So we have 1 of these, 2 of these, and 3 of these. It means the ratio is 1 to 2 to 3. Okay, so there's 2 aluminiums for every 1 aluminium oxide, just like there's 3 oxygens for every 1 aluminium oxide. Here the ratio is 2 to 1 to 2. There are 2 calciums for every 1 oxygen, and there's 2 calcium oxides for every 2 calciums. So between these two, they're 2 to 2, which means 1 to 1. Between these two, they're 1 to 2, and these are 1 to 2. Last example, we have 1 of these, 5 of these, 3 of these, and 4 of these. So it depends which way you look at it. The ratio between this and this is 1 to 5. The ratio between water and carbon dioxide is 4 to 3. So that's what ratios mean. Now back to our actual question, how to solve these. My recommended method is that you firstly underline the key parts, calculate the mass of aluminium. So I'm going to put a question mark here because that's what they want us to find out. They can be formed from 1020 grams of aluminium oxide. So I'm going to put 1020 here. That means the sole focus is on these two. We do not care about the oxygen. Now, to solve these questions, the first thing people find difficult is they think, well, I need to find mass, so I must use the mass formula. The thing is, you can't just find the mass of aluminium because you don't know anything about it, except you know its relative atomic mass is 27 from the periodic table. That's all you know. So you can't actually do mass equals moles times mR because you don't know the moles. So what you do is you follow my 3-step method, which I call the Mr. M method. Step 1 is moles. Step 2 is ratio. And step 3 is mass. These will normally be 3 marks or more. So firstly, moles equals mass over mR. Now, you start with the moles of whatever they give you the mass of. Because as I said, you don't know anything about aluminium, so you can't do it. But for aluminium oxide, we know the mass is 1020. So I'm going to write 1020 divided by, I must use the MR of this. So for the aluminium oxide, make sure you look at the periodic table. Aluminium is 27. So 27 times 2 plus 16 times 3. Oxygen is 16. That gives you a total of 102. So that's your MR here. When you divide these, you get 10 moles. Next, you look at the ratio. The ratio is, I'll write it over here, 1 to 2 between these two. Now, I just worked out the moles of the aluminium oxide, so I'm going to put 10 here and a question mark here. Well, if 1 goes to 2, then 10 goes to 20. So I'm going to write 1 to 2, and I'm going to write 10 times 2 equals 20. Okay, and that will be 20 moles of aluminium. And the question asks for the mass of the aluminium. So mass equals moles times mR. That's how you rearrange this formula. Or if you prefer the triangle, it looks like this. Remember, moles is N, not M. So then make sure you do 20 times, and then MR or AR. In this case, an element, so it's actually AR. Do not make this mistake. This is one of the misconceptions. People see a 2 here, and they do 2 times 27. That's wrong. You only include little numbers, subscript numbers, if you're doing an MR. So it'll be 2 times 27, which gives a final answer of 540 grams. So the reason you don't include the big 2 is that that's the whole point of the ratio step. That's why you don't need to do it twice. Okay. So only little subscript numbers. Let's try the next example to freshen it up. So moles is the first step. Without even thinking, I'm going to write this. Now, 10 grams of calcium means this one. To form, so it forms calcium oxide, but it says calculate the mass of oxygen. So we're looking for this one. So we can ignore this. So my first step is to do 10 over calcium. Now, if you look that one up, it's 40. So that gives you 0.25. Second step is the ratio. The ratio is 2 to 1. So if this is 0.25, then this oxygen must be half of that, which would be 0.125. Then we do mass, step 3. Mass is moles times MR. The moles is 0.125. Now the MR of oxygen, remember oxygen is O2. The little numbers do count. So it is 16 times 2, which is 32. And that gives you a final answer of 4 grams. And that's our second example done. I think one more example might be a good idea. So let's do number 3. So mass of propane, this is propane, 50 grams of oxygen, this is 50 grams. So first step, moles. Moles equals mass 50 over oxygen 32, because oxygen is O2. Remember, the big 5 doesn't count here in the MR. So 50 divided by 32 would be your first step. Second step is ratio. Now, also, I forgot to mention, it's important that you do not actually round your answers. You try and use the exact values on the calculator. You can write rounded values here, but you must use the exact values on your calculator. Now, the ratio, interesting. Is it 1 to 5 or 5 to 1? Well, because we found the oxygen and we're looking for the propane, it's actually 5 to 1. So we need to divide this by 5. So it'll be 50 over 32 divided by 5. I will actually input this now into the calculator. So 50 divided by 32 divided by 5 gives me 0.3125. And then mass finally is moles times MR, so 0.3125 times. Now we need the MR of the one we're looking for. Don't make the mistake of putting the MR of oxygen again. So you look at this, it's 12 times 3, and it's 8 times 1. So 36 plus 8 is 44. So if I multiply this on my calculator, my final answer is going to be 13.75 grams. So I've done 3 questions. I'll save this whiteboard so you can have it for downloading purposes. And I strongly urge you to look through the example and use it as a guide to try the next questions. So this is saved now. There's one style of question which we didn't look at, and is this one with the dot, the water of crystallization. Now, this type of question can occur, so I will show you how to do it. There's only one here, but there's one on the other worksheet too. So this will be our final example. We have 10 grams of hydrated sodium sulfate. Hydrated means you have water, so this is 10 grams. It decomposes, so breaks down to form 4.4 grams of anhydrous. Anhydrous means without water. So this will be 4.4 grams. Now, how much water will be formed? You can just take the difference between the two because of the conservation of mass principle. So this will actually be 5.6 grams. 10 minus 4.4. The question is to find x. Now, if you think about it, the ratio is 1 to x. So we need the moles of these two, and then we can just do x divided by 1. So we can do the moles of this divided by the moles of this. You cannot find the moles of this directly because x represents a number. We do not know how many waters there are. So remember, the dot means water of crystallization, and it means that there's a certain number of water molecules inside the sodium sulfate crystal. Therefore, we can't actually work out the MR here because we don't know how many waters to add. So we can only work out the moles on the right. So for the first one, it will be 4.4 over the MR of this. So sodium is 23 times 2, plus sulfur is 32, and oxygen is 16, and 16 times 4 is 64. If you add these up, you get 96 plus 46, which is, 96 plus 46, 142. And for water, we know it's 18. Remember, the big numbers in front don't count, so we do not care about this x. So it's 16 plus 2 times 1, 18. Now, if we divide these two things, we get the following. We get, for this one, 0.030986. I've done a small bit of rounding. Ideally, you would keep the value, but if you write 4 significant figures or 4 decimal places, you will get it right. So this now gave me 0.311 recurring. Now the trick is do the bigger number divided by the smaller number, because you're doing x divided by 1, which gives you x, and that's what you're looking for. So 0.311 recurring over 0.030986. Put that into my calculator. I get a nice answer of 10.04, which essentially equates to 10. So the value of x is 10. So my method was deduce the mass of the anhydrous one in the water, find their moles by doing mole mass over MR, and do the bigger number divided by the smaller number. You will see more of these questions when we look at some of the experimental ways of finding empirical formula, molecular formula, and water of crystallization. But this is like your first introduction to it. Worry more about the first questions rather than this one. This one was more of a bonus here. Okay, that's the end of the first lesson, reacting masses. And the next lesson will be on percentage yield. So see you next time.